till now we have seen various DFAs and various operations we did on DFAs, but then I didn't actually explain what is the operation I was carrying out when I was solving some problem. Now I'll explain you by taking examples of all the DFAs we have seen till now, and I'll tell you how to apply some of the operations on DFA. They are all the operations which you can apply on DFA. For example, I can take two DFAs and then I can apply union, or I can take two DFAs and then I can apply concatenation or cross product or complement or string reversal. So I'll take each one of them and I'll explain you. Let us say we have seen already this problem where we have to accept set of all strings which starts and ends with different symbol. Let us assume that sigma equal to a comma b, and in this I have to accept set of all strings which starts and ends with same symbol or different symbol, right? So if you consider it, the language contains two parts. One is it should start and end with, it should start with A and end with B. It should start with A and then it can contain anything and end with B. It should start with A, contain anything, and with B, so on. And other languages, it should start with B and it should end with A. It should start with B, contain anything in the middle, and end with A. It should start with B, contain anything in the middle, and end with A, so on. So our language, our required language which starts and ends with different symbols contains two parts here. One is starts with A, ends with B, starts with B, ends with A. So you can actually do it this way. Construct the one for starting with A and ending with B, right? So if it is going to start with B, I am going to kill it, and it can contain any number of A's in the middle, and if it sees any A, it is going to come back and wait for a B, and it sees any B, it is going to. So this one is representing L1, this one is representing L1. Now you can even write it as L2 is starts with B and ends with A. So if it starts with B and ends with A, I accept it. If it starts with A, I am going to kill all the strings, and in this state I can see any number of B's. If I see a B here, I will wait for a and I can see any number of A's here. So this is starting with A and ending with B, this is starting with B and ending with A. And now if you go back to the example where I have combined it, the final diagram is I'll have the same start state. I wanted to union these two. So whenever I wanted to union these two, what I could do is I can merge these two start states, which means I can keep this part and I can take this part and join it here. I can take this part and join it here. If you see the diagram, it looks like this. It can start with A and end with B, I accept it, or it can start with B and end with A, I accept it, and in the middle I can get any number of A's, and at the end I can get, if I get a I'll wait for a B and any number of B's. This one I have already explained in the previous example once, and so I'm not going to explain it again. In this state I am going to see any number of B's, and here if I see a if I see any number of A's, it is ending with A. If I see a B, I'll come back. Now check it. This part is actually this part, and this part is actually written here. Try to understand this. This part is actually kept in this row and this part is actually here, which means if I have L1 and a DFA 1 for L1, and if I have a language L2 and a DFA 2 for L2, what I could do is, in order to obtain for L1 union L2, I can take a start state, and on one way I can put D1 and on other way I could put D2. So this is also called as union. So in this example we have seen how, without showing you what is union and how to apply it, I have directly applied it, and now you can understand how to apply union for any such problem. Okay. Now let's see how to apply concatenation. So what is a concatenation is, let us assume that one language L1 is there. L1, let us say, contains set of all strings starting with A, and let us say I have one more language L2 which contains set of all strings ending with B. Okay, so let me write the strings. Starting with A means A is the smallest string which is going to start with A, and AA is the second smallest, AB, A, so on, and L2 is ending with B. Smallest string which is going to end with B is B or AB or BB or AAB, so on. Now what is concatenation of two languages is, you can take any string from this. If I have to write L1 concatenated with L2, you can take any string from L1 and concatenate with any string with L2, which means I can take A from here and B from here, and I can write it as A concatenated with B, which is AB. Or I can take A from here and AB from here, and I can write it as AAB. Or you can take AA from here and B from here, and I can write it as AAB, so on. So if L1 is going to be a language which is starting with A and L2 is going to be a language which is ending with B, now L1.L2 is nothing but a language in which set of all strings are going to start with A and end with B. So how we could do it is, let us consider DFA for L1 first. We have already seen this example, so I am not going to take a lot of time explaining it. I will simply go ahead with the answer. Now let us say I want to construct the DFA for L1. DFA for L1 is, it has to start with A, which means A is the smallest string. I am going to accept it. If I see any B, I am going to kill it. Why? Because if I see a B, the string is going to start with B, and I should not accept it, and I will never accept it. If I have already seen A, then I am going to accept it, right? So this is the DFA for set of all strings which are going to start with A. Now let us construct the DFA for set of all strings ending with B. Smallest string which is ending with B is B, that is why the skeleton is this, and initially I can get any number of A's, and after seeing a B, I will assume that is a lost B. If I get any A, I will again wait for a B, and if I get any number of B's, they are still ending with B. So this is for L1 and this is for L2, right? So actually for a language, we have already seen this. For a language which starts with A and ends with B, the diagram is going to be like this. I have already shown you previously, so I am not going to explain it at detail. If a language is going to start with A and end with B, the smallest string is going to be AB. I am going to accept it. If it starts with B, I have to kill it because it doesn't start with A. So anything happens, I am going to kill it, and in this state I can see any number of A's, and once I see a B, I will come here and I will assume that is a lost B, and if any A comes, I will again wait for a B, and any number of B's I will be here. Now if you look at this diagram, L1, L2 and L1 concatenated with L2, you can observe one thing. This entire part of DFA is present here. Check the similarities, and this entire part of DFA is present here, right? Therefore you just observe it, observe this one. This entire part of DFA, this part has been shown in this picture, and this entire part of DFA has been shown in this part, which means if I have two languages L1 and L2, and D1 and D2 are the automators which represent L1 and L2. Then in order to concatenate L1, L2, I have to simply take D1 and concatenate with D2. I have to simply take one DFA for first language and concatenate with the DFA for the second language. So this is how concatenation method works. So you can think about any other problems where you can apply this. See, a string can start with anything and end with anything. Then you can see, the question is, a string has to start with something and then it can contain anything in the middle and it has to end with something. Then you construct the DFA for this starting part and you construct the DFA for this and try to concatenate it, right? Only thing is, the final state in the first DFA is going to be the initial state in the second DFA. The final state of the first DFA and the initial state of the second DFA should be merged, and the transitions have to be changed appropriately. That is the only thing you should remember. What is it? The final state of the first DFA and the initial state of the second DFA should be merged, and then the transition should be taken care accordingly depending on the language. Okay, so this is about concatenation. Next one is cross product method. We have already seen an example where, let us say, L1 is set of all strings containing even number of A's. So 0 number of A's and 0 number of B's is even number of A's, or 2 number of A's is even number of A's, and then I can contain any B, even number of A's only, even number of A's, or 4 number of A's is even number of A's. So this L1 is set of all strings containing even number of A's, and L2 is, let us say, set of all strings containing even number of B's. So A, B, 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 A, B, or so on. Fine. So now we have seen two languages. One is set of all strings containing even number of A's. It can even contain only B's also, right? B, 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 so on. And set of all strings containing even number of B's, which means it can even contain any number of A's also, right? So one method is, if I have to construct a DFA which accepts set of all strings in which number of A's are even and number of B's are even. I have to construct a DFA which accepts set of all strings in which number of A's are even and number of B's are even. Then what I could do is, I can construct separately DFAs for them. This is even number of A's and this is even number of B's. Let us say the state is A, B, C, D. Then we have seen how to combine them, right? We have applied a method called cross product, in which we have taken A, B states and we have applied cross product with C, D, and then we got a final answer with AC, AD, BC, BD. You can please refer to that example in which I have solved this question. Now what I wanted to say is, whenever the question is like this, and, or, not, something like this, even number of A's and even number of B's, even number of A's and not even number of B's, which means odd number of B's, or even number of A's or even number of B's. Whenever a question is containing two parts and in the middle if it is separated by and, or these connectivities, then you can take the diagram for each one independently and you can apply the cross product, and then whatever is the final state in each one of them. For example, here the final state is A and here the final state is B, then the final state is going to be AB, AC. Okay, so depending on that you can decide the final state. Depending on the question you can depend the final state. And in some example we have already seen complementation. So what is a complementation? Let us say, I'll take an example. Let us say L1 is a language which contains set of all strings which are containing A. So L1 is a language which contains set of all strings containing A. So if I write L1, L1 is going to be smallest string which contains A is A or AA or BA or AAA or BAB, which means it should contain A somewhere. So this is the L1. Now if I take L1 complement, it is nothing but set of all strings which does not contain A. Definitely epsilon is there. Why? Because epsilon doesn't contain A. And definitely B's, any number of B's are there, so on. So it is nothing but containing only B's or epsilon, right? So let's draw how to do this is, let us say already have finished a DFA for one problem, complementation. If it is does not contains, then what you could do is find the DFA for containing A and then you can complement it. What is the DFA for L1? Set of all strings containing A, and I accepted. Any number of B's, I'll wait for A and AB. This is the automata DFA which accepts set of all strings which are containing A. Now what you should do is make all non-final states to final state and final state to non-final state. So the complementation is this: non-final state has to be made final and the final state has to be made non-final, and the rest is same. Now check this. So initially any number of epsilon will be accepted, any number of B's will be accepted, but if I see one A, that will be going to dead state and will be rejecting everything from there. So if we have already seen this, but still I am saying that if Q is a let us say L1 is a language and DFA accepting it is Q, sigma, delta, F and Q naught, then the complement of this is nothing but take the final states and you write Q minus F. Just change the non-final states to final and final state to non-final. That is complementation. Now let's talk about reversal operation. Reversal operation is nothing but if I take a language and if I have to reverse the entire language, then what I should do is take each string in the language and reverse it. For example, let us say L1 is a language which starts, in which set of all strings starts with A, which means L1 contains A because it is going to start with A, or AA because it is going to start with A, AB starts with A, AAA, AAB, ABA, so on. So L1 is going to contain set of all strings which are going to start with A. Now let us assume that I have to reverse it. L1 reversal is nothing but take each string and reverse it, take each string and reverse it, take each string and reverse it, each one and reverse it, B, A, B, A. If you look at this language will be ending with A. If the initial language is starting with A, this reversal language will be ending with A. See this. The string is there in this language LR, but its string is not there in the initial language, right? So how we can form the reversal is, first of all, draw the DFA for the original language. First starting with A, it starts with A, I am going to accept it. If it is starting with B, I am going to reject this string. I am going to reject this string, dead state, and then follow these steps. Let us say A, B, C. Draw the states as it is, A, B and C. Now make the final state as initial state. Final state is initial state, and make the initial state as final state. Initial state as final state, and if there are any edges, you just reverse them. Since there is an edge from A to B on small a, you just reverse it this way. and since there is an edge from B to C, you just reverse it this way, and loop will remain the same. Loops, they will not change because they are from B to B, therefore B to B, and they are from C to C, therefore they will remain C to C, right? And just observe the diagram. In this diagram, the node C or the state C will never be reached. Actually, if you look at this, the state C will never be reached, therefore C is useless. You can remove it, right? And this is the final diagram. But if you look at this one, it is not DFA, because on capital B, on small a, you are giving it two directions, which means you can stay in B or you can go to A, and on capital A you have not given any transitions, so it is actually NFA. So I don't mean to say that every reversal is going to lead us to NFA. What I wanted to make it clear is, if I reverse the directions of the transitions and if I make initial state as final state and final state as initial state, what I get is the DFA, or a finite automata which accepts the reverse of the language. If for L1, if we have a DFA and if I reverse the DFA, I will definitely get reversal of the language, but then the resultant can be NFA or DFA. The resultant can even be NFA or DFA. Let us take one more example and I'll explain you. Let us say L1 is set of all strings of length 3. Set of all strings of length 3, or you can even take set of all strings of length 2. Let us take 2. Let us say L1 is set of all strings of length 2, which means AA, AB, BA, BB. Now I want to reverse it. Take each string and reverse it, which is nothing but AA, BA, AB and BB. I have taken each string and reversed, each string and reversed, each string and reversed, each string and reversed. Now let me draw the DFA for L1. Set of all strings of length exactly 2. A comma B, A comma B, and this is the final state. And if I get any A comma B, I am going to kill it. A comma B. Now, in order to find the reversal of this language, I have to draw the states as it is, A, B, C, D. Let me draw the states A, B, C, D, and now make the initial state as final state, make the final state as initial state, and you reverse the directions. It was from B to C, now I made it from C to B. It was from A to B, now I am making it from B to A. It was from C to D, now I am making it as D to C. Right? So it turns out that the state D can never be reached from initial state, therefore you can remove it. And here also we got something called as NFA. It is definitely not DFA, it is NFA. What is NFA? What are its properties? We shall see later. But then understand that if I change the initial state to final state and final state to initial state, and if I reverse the arrows of a finite automata, I am going to get a finite automata which accepts exactly the reversal of the given language. If this accepts the language L, this one accepts the language L par R.